Hello and welcome to another episode of Recently in the Support. Today I would like to talk about CST Studio Suite and especially a topic which might be interesting for all users who are building networks in SPICE or in the circuit in CST Studio Suite. Yes, sometimes you would like to build a network, an RLC network, which is describing the impedance of a 3D model quite good. And that's not always easy. And I would like to show you some helpful tools in CST Studio Suite how to do this. Let's get in. Yeah, for this purpose, I have a housing here with two bus bars inside. The housing is bolted together with bolts, and we have two bus bars inside this housing and four ports, four lumped ports. So we have a plus bar and a minus bar, for instance, and we have some dielectric parts which are green inside, which have permittivity of, let's say, something like 3 or 4, a typical dielectric. So, of course, we would like to get some parasitic information, parasitic effects between the bus bars, both bus bars to each other and the bus bars to the housing. And that is not always easy because we have some dielectric in at some parts and at some regions we don't have. Of course, we could use the Y parameters and the Z parameters to get out the information. But as you see here, this is a typical RLC network that we would like to build. We have some local L's and C's, so those are partial inductances and partial capacitances, the so-called parasitic capacitances, which we have to put some values in. How to get the values? Yeah, of course, it's possible to use the full wave solver and the Y parameters and the Z parameters, but that's not quite easy because we always have the complete current loop in. So let's switch to a different solver, which is called the partial RLC solver. And that is exactly for that purpose. It's a low frequency solver, but we can use it here for that example also. The housing will be the ground. So we put a ground node on the housing. So the housing will have one potential. And the other parts, the minus and the plus bus bars, we divided into several sections, as you see here. In those sections where we expect a different behavior concerning the parasitic capacitances. So the area with dielectrics we cut out, the areas without dielectrics we cut out, and then we are able to calculate them separately. Because this partial RLC solver is really able to calculate partial inductances, which is not physical, but which helps us to put some values into our circuit model. Yes, here we see, for instance, the first part of the plus bus bar, we have an input and we have an output, and the solver will calculate the partial inductance between the two in and outputs. The same here for this area where we have the dielectric. We have the plus bus bar section in this dielectric. We have an input and an output, and so we get the partial inductance and the partial capacitance in this section. Yeah, that's quite easy to define. And then when we solve it, we have to go to the setup. We can define all the pairs for in and output for all the sections we defined. And then we calculate it. And as a result, we get the complete matrices. So what is interesting for us now, because we want to use it in an RLC model, it's the lumped capacitance, the partial lumped capacitance, and we get all the values. So the values to the ground, the values between the bus bars, and so on. So we get everything we need to put into our RLC network. The same is for the inductance. We get the complete matrix and all the coupling effects, and the same for the resistor. So we get all the partial resistances and also, if we want, some coupling effects. So that's enough for us to put it into our RLC network, and we are able to get a behavior which is very near to the reality very near to the 3D full wave model. And it helps us to build up some RLC networks for white box modeling and so on. So I hope that helps you. And if you're interested in more information, contact us. We can show you some more. That's it for today. Thank you very much for watching. Goodbye.